Swayam Prabha. Digital India. Educated India.
Morning students, welcome to this lecture on the double diamond design process for innovative smart products, and move on to the next phase of the double diamond and look at how we can develop solutions. So, at the end of today's lecture, you would have understood and learnt how to articulate what product concepts are. Okay. So, you will understand more about product concepts. You learn how to generate new product concepts using a 5-step method, okay. And you would have learnt how to apply key principles in the selection of product concepts. So, to recollect, the double diamond design process again has this problem domain and then this solution domain. Okay. So, we are now done with the problem domain. Okay, we have learnt about discovery, we have learnt about define, and now we will move on to develop. Okay. In develop, we will focus on and develop a solution. So, what are these product concepts? So, a product concept is a technical description of how the product will satisfy the customer's needs. Okay. So, a description of how this product will satisfy the needs of the customer. So, this description is a technical description. So, it is not just in writing, it is not just a set of sentences. Okay. So, there has to be some technical information going with it. Okay. So, that can be in the form of engineering drawings, for instance. Okay. So, that can be in the form of electrical CAD models. Okay. So, a technical description of how the product will satisfy the needs of the customer. It is an approximate description of the technology that you will use, the working principles that you will use, and the form of the product. Okay. So, what technology are you going to use in your product? Will you have some embedded sensors in it? Okay. Will you have some internet connectivity in it? Will you have some inline drive systems in it? Okay. So, that will form part of your concept. How will the product work? Okay. So, how is the force being transmitted? How is the current flowing in the circuit? Okay. So, the working principle of the product will be described in this concept. And the third thing that the concept will have is the form of the product. Okay. So, like a sketch, like an engineering drawing. Okay. So, that will tell users about the form of the product. Everyone understands? So, often this product concept is expressed with a sketch or a 3D model, which is accompanied with a brief textual description. Okay. So, typically the product concept has a sketch or a 3D model, and this comes together with a text description. Okay. So, the way you illustrate your concept is one sketch or a 3D model and some text description of what it is, and that text description will have details of the technology used and the working principles, and the sketch or the 3D model will give you the form of the product. Everyone follows? So, let us look at an example of a concept. Okay. So, here is an example of a concept, and this is taken from a US patent. Okay. So, typically patents will carry such illustrations. Okay. So, this is the concept from a motor driven double flywheel nailer patent. Okay. So, this is a nailer, which means it places nails in objects. Okay. It is able to fix nail into objects, and this is driven by a motor and it uses a double flywheel. So, motor driven double flywheel nailer. Okay. So, you can see how complex this concept looks like. The accompanying text describing the patent is 9 pages long. Okay. So, this accompanying text also forms part of the concept. Okay. So, this is the actual physical device. So, the nail comes out from here. So, there is some handgun and you press on that and possibly there is some electrical supply and then the nail goes in and goes inside the object such as a piece of wood or some wall, etc. Okay. So, now we move into how we can actually generate such concepts. Okay. So, now once we talk about concept generation, there is the good versus the bad. Okay. So, there might be good concepts and bad concepts. So, bad concepts are ones that consider only one or two alternatives, okay, and they fail to consider the usefulness of the concepts. Okay. They may involve only one or two people in the process. That is why some of you are working in teams, you can use that to brainstorm and discuss about the merits and demerits of different concepts. Okay. Bad concepts ineffectively integrate promising partial solutions. So, for a given problem definition, you might have something that only partially solves the problem. Okay. But can we integrate the partially good solution together with another solution to create a much better hybrid solution? Okay. So, it is bad concept work if you can't integrate some promising partial solutions into a final concept. And that is why I have been insisting that you go through your double diamond with a lot of care. Okay. So, and really work through the double diamond. So, there might be several promising concepts to a same challenge problem, and that is what also you must try to bring out in your portfolio. So, bad concepts ineffectively integrate promising partial solutions. So, we will see what that means. Okay. I will show you an example. Bad concepts fail to consider entire categories of solutions. Okay. So, there might be an entire set of solutions which you do not at all consider, you just forget about them. Okay. So, how do we go about generating good concepts? So, to generate good concepts, we need some kind of a systematic procedure. So, today we will learn about a 5-step method that helps us generate good concepts. Okay. So, the first step is to clarify the problem. Okay. What is the problem? Okay. Then you want to search externally. You may want to search some external sources. You can search internally. There might be something within your company or many different solutions within your company that you could use. There must be know-how. Okay. Then you want to be exploring systematically. So, we will discuss, many of you are thinking, well, what does it entail? What does searching externally entail? What does searching internally entail? And then you want to be exploring systematically, and then you want to be reflecting on the solutions in the process. Okay. So, there are specific techniques for exploring a set of solutions. So, we will learn about that here. Okay. So, searching externally and searching internally can occur parallelly. Once you have clarified the problem, you can do these activities parallelly, and once you have done that, then you can explore systematically and finally reflect on the solutions in the process. So, now clarifying the problem. How do you clarify the problem? Firstly, you want to be understanding the problem. Okay. So, this understanding can come from the team's mission statement. What is the mission statement of your team? Okay. Is it to develop an improved nailer? Is it to develop an improved device that is cheaper than what exists in the market? Okay. Is it to develop a completely new product or a variant? Okay. What is the mission statement that is driving your team, and that is the first step in understanding the problem. Then you can understand it from the customer needs. Okay. So, what are the needs of the customer? You have already done that customer need mapping in the discover and the define phases. Okay. From the product specification. So, at the end of the define phase, you have got some target specifications. So, use them. Okay. So, once you understood the problem, then you want to be decomposing the problem into simpler sub problems. So, decompose that problem into small sets of problems. Okay. So, you can do it in several ways. You can you can use divide and conquer to decompose the problem. Okay. You can use function diagrams. Okay. So, you can list out all the functions that this device will carry out, and then you can see how this function will be achieved with sub functions. Okay. Like supply electricity to the nailer. Okay. Push the trigger with your arm. So, you can use different sub functions which add up to a final function. So, that is decomposing the problem in terms of functionality that you want from the product. Okay. So, you can decompose by sequence of user actions and you can decompose by key customers needs. Okay. What are the steps one after the other that the user will do so that the final function is achieved? And you can decompose by key customer needs. So, customer may have 5 needs from the product and then those 5 needs can be the 5 sub functions that add up to the final function. The next thing you want to do in clarifying the problem is to focus your initial efforts on the critical sub problems. So, you may have 10 sub problems here, out of them 2 may be the most important ones, which are the difficult ones to achieve. So, of those 10, you spend most of the time looking at those 2 problems. Okay, identify those 2 and then focus on those sub problems. So, other sub problems you can defer the solutions. Okay, you can carry out the solutions later. So, now let us look at the example, okay, how we can understand the problem in case of the power nailer. So, this is the black and white image of that same power nailer. Okay. So, from the mission statement we understand that this power nailer which we are trying to devise, it will use nails. Okay. It will be compatible with nail magazines. Okay. Why? Because nail magazines are already available in the market and there are nailers already available in the market. Okay. And so, these nail magazines, if they are compatible with the product that you will design, then it is much easier, it is a lot easier for your customers to replace that nailer when replace the magazine when it goes out of shape or requires maintenance or has worn down. Okay. So, it must be compatible with nail magazines. The third thing that we understand from the problem statement is that it will nail through roofing shingles into the wood. Okay. So, it will use nails, but these nails should nail through roofing shingles into the wood. Okay. So, the nails should go into the wood and it will be handheld. Okay. So, a human being will hold the nailer and place the nailers into the wood. Okay. So, the mission statement has been broken down. So, it is a combination of these 4 statements. So, basically it is a bigger statement which has these 4 sub statements, okay, all packed together. And then, so the mission statement could be something like the mission of this product development exercise is to develop a power nailer that can send nails into wood, okay, at a fast rate. Okay. And then you can break it down into sub statements. Okay. So, then you use a set of assumptions that help you understand the problem slightly better. So, these assumptions could be something like the nails should be inserted in rapid succession. So, we do not want the nails to be going in very slowly and into the wood in 5 minutes, right, then it is no good. Okay. So, one of the functionalities of this product which we expect, and this is sort of an assumption that comes from common sense, is that it will insert nails in rapid succession. The second thing that we may expect out of this nailer is, because it will be handheld and a human will hold it, it can't be like 50 kilograms in weight, right. It has to be something that a human can hold. So, maybe 2, 3, 4 kilograms at the most. And thirdly, that it has no nailing delays. Okay. So, the user should be able to go from one to the other okay, quickly. there shouldn't be any delays. So, the delays may not be because it does not push it quickly into the wood, the delays may be because you have to do something else before you can nail the next one. Okay. So, those sort of delays have to be avoided. So, there are a lot of intricate functionalities in any product that you have to carefully think about. Okay. If you take a simplistic view to product development, often you will not come up with a good enough product. You have to really think deeply about the problem, and that depth of thinking has to reflect in the breakdown of your problem statement. Also, at the end of the define phase, we have come up with a number of target specifications. Okay. So, these target specifications, the examples are here. So, the nail length ranges from 25 to 28 millimeters. So, you remember the target specifications had a metric and a value, a metric and a value. So, a metric could be something like the length of the nail, okay, and its range is from 25 to 28 millimeter. The next metric could be the nailing rate, okay, and this nailing rate could be 1 nail per second. Okay. So, this could be another metric, and the third metric may be that the tool mass is less than 4 kilograms. Okay. This whole thing is less than 4 kilograms. So, these are there in the target specifications. Okay. So, how do we perform the next step, which is the external search? So, the external search, as we talked about earlier, could be from lead users. Okay. So, lead users can be ones who will most likely benefit from any improvement in this product, and they will also tell you the innovations that are required. Okay. So, if somebody is using the product day in and day out in their company, okay, or for their business, then they will know what is the shortcoming in that product. The IoT health monitoring system that you are talking about, there are doctors in our health center here, they will be the lead users. Okay. So, they will be the ones who will monitor the health of a patient. So, if you can get 5 minutes of their time and talk to them about it, they might give you some insight that you can include in your practical project, okay, and it will take the value of your project report a notch higher by including the lead user feedback and incorporating their suggestion into your product. Okay. So, likewise for your smart windmill project, the sustainable energy department, they might be one of the lead users. There will be people there who are looking into electricity generation from windmills. So, if you talk to a professor who is looking into electricity generation from windmills, they will be one of the lead users. The other could be a company like Suzlon. Okay. So, they are into the wind energy market. So, if you talk to a representative of Suzlon by contacting them over their website, okay, or through the alumni networks that we have, then they might be able to give you some useful ideas to create a better prototype. Okay. So, next way of carrying out an external search is by looking at competitive products. So, that will help you create some benchmarking stats. Okay. So, these competitive products will be found in trade magazines, they will be found in manuals, the product manuals that companies have available on company websites. Okay. You can get benchmarking information from technical papers which will have compared several products. Okay. You can get it from eBay, from Amazon, etc. You can also consult experts, okay, who are technical experts or they are experienced customers. So, a person who has been using this device for the last 10 years, 15 years, okay, in his house is an experienced customer. Okay. So, when you are interviewing customers, you can ask them, okay, how long have you been using such a product? What is the need that you have for such a product? Okay. How often do you use it? So, these are sorts of questions you can ask on the survey. Then you can look at patents. So, very often people forget that patents will give you the latest ideas, okay, that you can use in your product development exercise. So, do that and then also look at the literature. Okay. So, this will be technical journals and trade literature. So, as I was saying, trade journals and technical journals and scholarly papers, all of that will have a lot of useful content. So, every month Materials World comes out with a new issue of its magazine, and that will have a lot of knowledge about new materials, how the new materials are being processed to create new products. Okay. Likewise, there are many such magazines and journals which will have lots of details, okay, that you can use. And then you can carry out an internal search in parallel. For your internal search, it is crucial that you do not judge, okay. Suspend your judgment, okay. Generate a lot of ideas. Okay. So, by suspending judgment, you can generate a lot of ideas. So, if you get in a bunch of people, your team, to talk about this new product that you are wanting to develop, you do not want to be judging anyone. Let them come out with the most silly ideas, okay, and then that will help you generate a number of ideas. So, welcome ideas that are infeasible, that seem infeasible, and then use graphics and physical media. So, use the tools that we have got today, all the graphical multimedia that we have, okay, and the physical media that we have, use that as a guide for your search. Okay. Some hints for generating concepts. Can you make analogies? Okay. So, what other devices solve a related problem? So, for the power nailer, what is an analogous object? Hammer, yes. What else? Stapler. So, that is the best analogy, okay, the stapler. So, use these analogies. What is that stapler doing? How is that stapler stapling that pin, inserting that pin into the paper? What is happening? How is the force being transmitted? So, that staple which has a rectangular cross section is getting folded at the edges, okay, once you apply the pressure, right. Yes, gun, yeah. So, you can use the concept of gun, okay, to nail the nails. So, just the thumb will not help you generate enough force to nail into wood, right. So, we need to use the entire fist to nail the nails into the wood, right, and to use that entire fist we need some kind of trigger. So, some kind of a gun like mechanism, okay, like a trigger used in a gun. So, make analogies, okay. Think about other devices that solve the related problem. So, somebody said stapler, somebody said gun, somebody said stamping press. So, all of those are analogies. The other thing that you need to do in your internal search is wish and wonder. So, use related and unrelated stimuli, okay. So, any stimulus that is related and also unrelated, all of that can help you get new concept ideas. Okay. So, maybe you are sat in front of a television and you are seeing something on TV in a serial, and then you pick up something, you see something happening there, okay, and that is unrelated stimuli. Okay. So, once you have that problem definition in mind, your brain is always working and you are doing other activities, but you might get that Archimedes moment from doing something unrelated, participating in Antharagni, okay, and you might get some good idea from somebody playing EDM music. Okay. So, the next thing that you can do is set quantitative goals. Okay. So, while doing your search, well, depending on the duration of the project that you expect, you need to decide how many concepts you are going to generate. So, set a threshold before starting out, and once that threshold reaches, then stop. Okay. Then you can move on to the next phase. So, do not make the process arbitrary, that is the point. Okay. Set some quantitative goals, 10 concepts, 20 concepts, 100 concepts, how many would be enough. Okay. So, this we learnt last week as well. So, posting ideas on the wall, that is a good idea. Okay. Posting different ideas, grouping them, etc. So, here are some example concepts for the nailer. So, two sub problems were identified of the original problem. One sub problem is that we must be able to store or accept energy, and the second is that we must be able to apply translational energy to the nail. Okay. So, get the energy from somewhere, maybe from the hand, maybe from some chemical reaction, and then apply that energy to that nail, so that the nail goes into the wood. Without energy, the nail will not go into the wood, right. So, this storing and accepting energy, again if you break it down or you come up with concepts to brainstorm, the team in this case came up with all of these ideas. Just worth looking, how many concepts one can think of for just this simple, seemingly simple problem of making a power nail, okay, if you think out of the box. Self-regulating chemical reaction emitting high pressure gas, okay. Carbide, combusting sawdust from the job site, gunpowder can be used to store or accept energy, sodium azide, okay, that can form an explosive in an airbag, fuel air combustion from butane, propane, acetylene. So, you can use some fuel like butane, propylene, propane, acetylene. You can use compressed air, carbon dioxide, electrical wall outlet and cord, high pressure oil line, okay. So, hydraulics, flywheel with charging, battery pack on tool, fuel cells, human power, methane from decomposing organic materials, okay. Nuclear reactions, cold fusion, solar electric cells, solar to steam conversion, all of this is generating energy. So, solutions to a sub problem of applying translation energy to the nail is you can have single impact, you can have multiple impacts, okay, 3 or 4 times, tens or hundreds or thousands of impacts, or a push, okay, from some mechanism like that, or a twist and a push. So, that translation energy can be applied in many different ways. So, the next thing you can do is create a concept classification tree. So, here is an example. So, you can take all of these concepts, these problems to the, so all of these you can take all of these and you can create a classification tree like this. Okay. So, the storing or accepting energy problem can be broken down into chemical, pneumatic, hydraulic, electrical and nuclear, 5 different techniques. And again in chemical you can use fuel air systems and also explosive systems. For electrical you can use the wall outlet, batteries, fuel cells. Okay. So, again if you break it down like this, also innovative ideas will come through. Okay. So, you will be able to create something innovative that people have not tried before. Okay. And after you have done that, you can prune the less promising branches. So, maybe we do not want really explosive system for pushing nails into wood. Then identify your independent approaches to the problem. Okay. What are the different approaches which are distinct from each other, not overlapping. Expose the inappropriate emphasis on certain branches. Okay. So, maybe some branches are needlessly emphasized. Okay. Maybe pneumatic you are thinking too much on pneumatic. Okay. So, see if your classification tree can expose those sorts of emphasis. And then you can refine the problem decomposition for a particular branch. Okay. So, for this branch we have refined it into wall outlet, battery and fuel cell. So, that is refining. So, that is what classification tree does. So, from store accept energy into electrical, into wall outlet, into battery, then wall outlet can be further made into maybe some other branches. Okay. And then what you can do is create a concept combination table. So, this is concept classification tree and then you create a combination table. So, in concept combination table what you do is you can maybe combine wall outlet with battery or combine hydraulic with a wall outlet, and combine different concepts. Okay. All right. So, now let us look into refining the problem decomposition. So, you have created a decomposition of the problem, but now you can refine it further. So, what is the power that is typically delivered during nailing? During nailing, the typical power that is delivered is of the order of 10,000 watts, 10 kilowatts. Okay. So, now this exceeds the power that you get from your wall outlet. Okay. You do not get that much power from your wall outlet. It's a lot of energy. So, what we need to do is accumulate the energy over a substantial period. Okay, so, we need to accumulate, add up energy, and then we want to be releasing suddenly to supply instantaneous power. Okay. Energy per unit time is power, right. Joules per second is watts. Okay. So, release this energy, a lot of energy in a small second to supply the instantaneous power. Okay. So, 1,000 joules delivered in 0.1 second would give you 10,000 watts. Okay. So, release it suddenly to get that power that you need. Everyone understands? And then you can combine concepts. Here is an example of how you can combine the concepts in this case. So, you can see to convert electrical energy to translational energy, you can use a rotary motor with transmission, you can use a linear motor, you can use a solenoid, or you can use a rail gun. So, there are 4 different techniques that you have identified to convert electrical energy into motion. And then to accumulate the energy, you may use a spring or a moving mass. And then to apply the translational energy to a nail, you may use single impact, multiple impacts and pushing the nail. Okay. Slowly. So, you can now combine these 4 with these 2 with these 3. You can make all sorts of combinations. So, that is your concept combination table, just matching and creating all the combinations. Okay. So, combination 1 could be that a solenoid compresses a spring and then releases it repeatedly to drive the nail with multiple impacts. Solenoid, spring, multiple impacts. Okay. So, after doing that, you can come up with the statement of your concept, and that leads to a concept like this. Okay. So, here is your spring, okay, and there is a solenoid here, and then by making multiple impacts through this nozzle, you are able to drive the nail. Okay. The energy is stored in the spring, and that when it extends, then it is pushing this forward, so that the nails are going into the wood. So, the compression of the spring is storing that energy. How much is that? If the stiffness is K, how much is it? And if it is compressing by delta x, how much is the energy that you are storing? Half K delta x square, right. So, that again half K delta x square will let you get that 10,000 watts. So, you can do your maths around it. Okay. So, what stiffness spring should I choose? K. Okay. And how much can it move? So, that delta x can be maybe 2 centimeters, 3 centimeters. It can't be 2 meters, right. So, for a power nailer. So, accordingly you can choose your K. Make sense? So, it is a bit of common sense, it is a bit of science and using this systematic procedure. That is how you come up with new concepts. So, the other could be rotary motor with transmission combining with spring and giving a simple impact. So, this rotary motor could be through a cam mechanism, could be through a rack and pinion mechanism. Okay. So, this rotary motor combining with the spring of course, and giving just one impact, that could be another concept. So, the motor winds the spring, accumulating potential energy that is then delivered to the nail in a single blow. So, here you see this is the again using the rotary motor, okay, with the spring, and the impacts will be many different times. Because it rotates, okay, this has 3 every time it contacts. So, it rotates every time this contacts with this, there is force released, that is creating an impact. It is not continuous. Okay. So, when it goes out of contact, then there is no force released, and then when this comes into contact, it goes in again and again and again. Okay. So, that could be the third one. So, motor repeatedly winds and releases the spring, storing and delivering energy over several blows. So, you can combine a linear motor with a moving mass and give a single impact. Okay. So, here is a phased linear motor. Okay. This is a wrapped linear motor. So, these linear motors of different types, again linear motors can be of different types. So, you can refine it further together with some kind of a moving mass. Okay. There is a moving mass, there is a mass that is moving and that is accumulating the energy and that is driving the nails. Then you can refine your solution concepts. Okay. You can refine it and create more visually appropriate sketches. Okay. So, here you had just line sketches. From line sketches you can go into these sorts of more actual product like sketches, the final product like sketches. Okay. So, typically teams create several alternative classification trees. So, the classification tree which you saw earlier, they create many such classification trees and different concept combination tables from them. So, a lot of design work goes on. This is all the design work that you are doing. Okay. So, creating these classification trees, concept combination tables, then narrowing and refining, okay, rooting out the ones that are not useful, then considering the user interface as well. Okay. So, in this case what is the user interface of the gun? So, it is the trigger, right. So, that is where the user is interfacing with the product. Think about what interface you can use to deliver that energy. Okay. What should be a shape of that. So, that will give you that refined solution concept that looks like this or this or this. Think about industrial design, how can it be actually made in the factory setting? Okay. What kind of manufacturing processes you have? Do you have polymer based manufacturing process? Do you have metal based manufacturing process? What kind of shapes they can produce? Okay. So, that is all the industrial design going into your concepts. Okay. Thinking about that and also configuration. Okay. How should it be configured? Where should the magazine be? Where should the nails be kept? Where should be the place where the human applies the force to the magazine or the nail? So, think about how it should be configured, okay? How it should be oriented, what shapes it must have. So, that will give you a refined solution concept. So, here you had basic solution concept, okay? And then from the basic concept you go into the refined concept. And then once you have done that, so you have come up with these sorts of concepts. Okay. These are your concepts. Then you can reflect on the solutions in the process. You can think, well, did we have a wide enough solution space? Okay. Did we look at all different possible ideas that could solve the problem of nailing nails into wood? Could we have thought of any other function diagrams? Could we have added up the sub functions in alternative ways to create the total function? Can we find alternative ways to decompose the problem? Can we decompose the problem in many different ways? Can we use some additional external resources? Have we considered all possible ideas? Okay, have we generated all different ideas and have we thought about integrating the ideas together? So, consider that. So, that is the end of how you generate concepts, okay, how you generate concepts after you have had the point of view statement and target specification. We have jumped up one more step and we have learnt how we can ourselves create and generate these new concepts to solve our problem, okay, based on the POV statement and the target specifications, how to come up with new concepts. But now that we have new concepts, how can we choose the best concept? How do we know which of these concepts are right? Which of these concepts will create a real product that we can sell? Okay. So, that process of selecting concepts is also known as concept selection. So, once you have created your concepts on paper or using CAD, it is time to select. So, this involves narrowing the set of concept alternatives under consideration. So, narrow it down from 20 concepts, we narrow it down to 5 and then finally maybe 1 or 2. So, it is a convergent process, but this is usually iterative. Okay. It is a convergent process, but takes several iterations to come with the final concept, and then the concepts can be windowed down to a few, but also may be combined. Okay. So, you might have 3 concepts, you may even combine them in the concept selection phase. So, it is not just selecting 1 out of 10, it may be that 2 and 5 may be combined to create another 11th one. Okay. And then after several iterations, you can choose a dominant concept. Okay. So, remember here that the goal is not to select the best concept. Okay. So, as I was saying, not to select 1 out of 10, but to develop the best concept. So, this is we are in the develop phase. So, we are still using concept selection to develop the best possible concept. So, here are examples of a set of concepts for an outpatient syringe. So, you move into different slightly different problem definition. So, this is a syringe just like doctors use. Okay. So, here are a set of concepts. So, concept A consists of a master cylinder, concept B consists of a rubber brake, concept C consists of a ratchet, concept D consists of a plunge stop. Okay. So, different concepts are available. Concept E has a swash ring, concept F has a lever set, and concept G has a dial screw. So, different concepts, and you can see these are all sketches and they carry a lot of details. So, like here there is a plunger, there is spring, okay. There is a filled cavity, there is a sleeve, there is a rod, there is a pusher, there is a medicine vial. Okay. So, the doctor has to insert this medicine into the patient. So, this is one concept for it with a plunger, a cavity and the vial. Okay. And how they are grouped together to create this kind of a syringe. A somewhat very different concept is this one, which has a dial screw in it, using a screw. Okay. So, you can see for a simple problem, okay, if you do not look at existing solutions in the market, you can sit down to sketch, you can create various new ideas. Maybe all of them are even viable. Okay. And so, give them labels A, B, C, D, E, and the main mechanism you can write it next to it. Okay. And so, you have a set of 7 concepts from which you have to select one. So, let us talk about some concept selection techniques. So, one could be using external decision making. You can also have multi voting. So, if your team has 20 people, you can ask each member to pick a number of concepts and pick the one with the most, and then the one that gives the most votes, you can use a voting system to select a concept. Okay. So, there are pros and cons, okay, of the different techniques that we use. So, you may have 20 concepts. For each concept, you can write out what is the strength of this concept, what is the weakness of this concept. Concept A, strength, weakness, you can list those out. So, that can help you in selecting when you write out the pros and the cons. And then you can prototype and test. So, you may have some concept on paper, but unless you have prototyped and tested it, you do not know which one will actually work. So, build and test prototype for each concept and select based on a test data. You can also use decision matrices. So, the team rates each concept against selection criteria, and this selection criteria will have varying importance or weights. Okay. We can actually talk about 2 very specific stages in concept selection. One is known as concept screening and the other is known as concept scoring. So, concept screening is a quick approximate evaluation of producing a few viable alternatives, and that uses a screening matrix. Okay. And your concept scoring involves detailed quantitative comparisons, uses a scoring matrix. So, the screening process will help you go from a large number of concepts through to a smaller number of concepts after concept screening, and even smaller number of concepts after scoring, and then after concept testing you get your final best concept. So, that is known as your concept selection funnel. So, concept selection essentially has some steps. So, preparing the matrix using criteria. So, the selection criteria, time required to push the nails, etc., okay, aesthetic features. So, those criteria you have to set. You will need a reference concept for concept screening, and it may have some weightings. And then you rate the concepts on the scale 0, minus 0 plus or 1 to 5. Minus is negative, this on this attribute this concept is not very good. 0 is neutral, plus it is really good. Okay. Or you can give it a rating 1 to 5. Okay. 5 is really very good, 1 is very bad, and 3 is in between, okay, and then compare the different concepts to reference concepts. Okay, we will see how this is done. Okay, I will show you the matrices, and then you rank the concepts, okay, based on your weighted scores. For each concept, you will get a weighted score. So, let us say there are 5 attributes. For one, one of them you had all pluses. So, maybe then it is 5 pluses, okay, and for another concept you may have 4 pluses and 1 minus. So, 4 minus 1, so 3. So, that is a score, total score. And then you may combine and improve concepts. So, concept selection helps you combine concepts as well and improve your existing concepts. You remove the bad features and combine the good qualities. Okay. So, it is very important because different concepts will have different positive features. Okay. Can we take the positive features of different concepts and then create a hybrid concept which is even better than any of the concepts that we have already listed? Can we create this hybrid concept which is going to be an innovative product which is a patent? Okay. So, that is how you get to an innovative product, by removing the bad features of existing concepts and combining the good qualities. Remove the bad, incorporate the good, and then you can select the best concept, and that may be more than one. Okay. So, 2 concepts may end up with the same score, and you need to be aware of average concepts. Some concepts may be just so, okay, and may sometimes end up with the highest rating. So, you have to reflect in your team, okay, pros and cons, and then finally reflect on the process. Okay. So, that will lead to continuous improvement of your concept selection process. So, this is the Pew matrix, which I have told you several times in conversations, okay, that you must have a Pew matrix in your practical project report. So, these were the 7 concepts and the selection criteria. Just look at the selection criteria. How easy it is to handle that syringe by a nurse, okay, how easy it is to use it. Can you read all the settings on it? Can you make your dose meter accurate? 3 milliliters means 3 milliliters, how accurate is it? How durable it is? Okay. Can you use the syringe 20 times? Okay. How easy is it to manufacture it? Can you use injection molding to manufacture it if you have an injection molding process in your company? Can you use a CNC milling machine? How easy is it to manufacture, or do you have to go for some advanced manufacturing process? Then the cost will be higher. How portable it is. Okay. So, in the case of syringe, portability is important. You do not want a syringe that is this big and it will require 2 people to carry it to inject little dose of drug into one human being. Okay. It must be portable. So, these sort of selection criteria you have to come up. So, really the designer has to think about all of this. What must be my selection criteria? Listing it down in plain English, okay, writing it down, or in any language you are functioning in your work environment, okay, writing it down. And then for each one of these selection criteria, 0, plus or minus, okay, for each concept. So, that gives you sums of zeros, sums of pluses and sums of minuses, sums of pluses, sums of zeros and sums of minuses, and that then gives you a total score. Okay. So, 2 into 1 is 2, 5 into 0 is 0. So, 2 plus 0 is 2. Okay. This one here, 1 into 1 is 1, 4 into 0 is 0, 2 into minus 1 is minus 2. So, 1 minus 2 gives you minus 1. So, net score for each one of these concepts. Okay. So, that tells me that this reference concept, which is the basics. Okay. So, with respect to this reference concept D, you have chosen this as the reference concept. Are these better or worse? Okay. So, net scores are arrived at, and then you can give the ranking for each concept. So, A got 1, B got 6, E got 2, F got 3. Okay. So, that means the best concept was this. So, you can say yes to that. For E, you can get you have got a score of 1. So, 2 then 1, okay, then these are zeros. So, maybe for E the decision from the team maybe to select this. Then the third best concepts were D, F and G. So, maybe the decision for 2 of them is to combine, okay, and The decision for G is revise. So, you need to enter your concepts and your selection criteria. Okay. So, selection criteria will listed and then A, B, C, D, E, F, G, your concepts. The concepts are presented at the same level of the detail. Okay. That is important, that the level of detail for each concept should be the same. So, maybe you must not have one of them is a sketch, the other is a 3D model, then it is very difficult. Okay. So, same level of detail. If one is a sketch, the others are the sketches. Okay. If in one you are showing the detailed circuit diagram, you show it for the others as well. Okay. Same level of detail. If more than 12 concepts are available, you can use multi-voting techniques. Okay. And the team members can indicate the preferred concepts with dots. Okay. 3 dots for the best one, 2 dots for the second best one, and so on. And then concepts with the most dots are chosen for concept screening. So, the selection criteria are based on the customer needs. Okay. So, the selection criteria. Okay. So, these selection criteria, ease of handling, etc., they are coming from the needs which you have identified in your discover and develop phases. Okay. From there only you are getting. So, you asked different users, you have done your market research, that has given you the needs. The needs then become your selection criteria. So, do not list too many unimportant criteria. Okay. So, having hundreds of criteria is not helpful. Okay. Choose the best 5, 6, 7 important ones, and then choose a concept as the benchmark or reference. In this case, we had concept D as the reference. Okay. Concept D was the reference. So, how do you combine and improve the concepts? So, the one question you want to be asking is there a generally good concept that is degraded by one bad feature? Okay. Is there a primarily good concept that has one bad shortcoming to it? Can you make a small modification to improve this overall concept and yet preserve a distinction from the other concepts? Can you make small modifications to the overall concept? Are there two concepts that can be combined to preserve the better than qualities while annulling the worse than qualities? Can you combine two concepts to keep the good qualities and remove the worse than qualities? So, in the case of the syringe, D and F could be combined to remove worse than ratings. Okay. You combine D and F, and then concept G was bulky, so excessive storage space was removed. Then you want to be selecting one or more concepts. So, decide which concepts are selected for further refinement and analysis. Okay. So, decide which issues need to be investigated before a final selection is made. Okay. So, maybe there are some issues with each concept, there is some problems, there is some cons. Okay. And you have selected and ones for further refinement, and then you have A, G. In this case, you have A, E, G which has been improved, and D combined with F. So, you got 4 concepts out of 7, and you see 2 of those 4 concepts are not the original concepts anymore. The concept selection procedure has resulted in 2 new concepts. Okay. So, it is not just a selection procedure. So, this is the improved tile skew concept. Okay. So, there has been something to remove. So, and this is, so the bulkiness has been removed. Okay. It is no longer bulky, it has been made more compact, and then there is the one where D and F have been combined to create a lever stop mechanism. So, new concept sketches have come up in the concept selection process. You see. So, then you can reflect on the results. All team members should be comfortable with the outcome. Okay. So, once you have got your selected concepts, ask your team members, what do you think? Openly ask them. Okay. Are you happy that we have got the right concepts, or do you have a feeling inside you that no, this concept is not good? Okay. So, ask that. Okay. They should become comfortable, and that is also important, because unless they are comfortable, they will not help you with the rest of the product design process. You have to take everyone on board. Okay. If one of the team members is not happy, some criteria may be missing, something is missing, he is not able to articulate it, he is not able to say it, but something may be missing. Okay. Some criteria is missing and he is not feeling good about your final concept. Okay. Or the rating may be in error or not clean. Okay. The rating may have some mistakes in it. Okay. So, you may have made improper Pew matrix, your Pew matrix may be wrong. Okay. You may have to rethink your Pew matrix. If some team member is not happy. Why is he not happy? Go back to the Pew matrix and see where he is stuck with. Okay, is there another selection criteria that will give a different score for each concept? Okay, because at the end of the day, there is a customer you have to think in mind. You have to empathize with the customer. You have to think, will the customer be happy? You have set your selection criteria, but is that enough for the customer? So, ensure that the entire team is solidly behind the concept for further development. Take the entire team with you. Okay. So, now you are asking about the difference between concept screening and scoring. Scoring is similar to concept screening, but more refined. Okay. So, you see here the ease of use has been broken down into 3 further selection criteria: ease of injection, ease of cleaning, ease of loading. Okay. So, can I clean my syringe easily? Can I insert do the injection easily? Can I also load it with the drug easily? 3 different eases, okay, ease of use cases. And then you can have a rating from 1 to 5, where 1 is much worse than the reference and much better than the reference is 5. So, then you use this sort of a weighted rank, okay, weight into the score, the rating, sum it up to get your score. So, this is an example of concept scoring. It is more fine grained than concept scoring, similar sort of a thing, but you do not use minus plus 0, you use 1 to 5. Okay. By using 1 to 5, let us say ease of handling, you got rating of 3, okay, for concept A, okay, and the weight for this selection criteria is 5%. So, you can break up this 100% into which selection criteria are more important. The most important selection criteria you see is the accuracy of the dosimetry. We do not want to insert 5 milliliters of dose into the patient when the doctor has said 3 milliliters is the one that is correct. Okay. So, that is the most important. So, you give it the highest weightage. So, you can give different weightages. See how intuitive it is. These weights are also based on some logical thinking. Okay. So, multiply this 3 with 0.05, it gives you 0.15, and likewise for each selection criteria you get a score, add it up, total score for concept A is 2.75. Total score for concept DF is 3.45. If you do that, you see that concept DF is better. Okay. Follow? You understand the difference? Yeah, everyone? Between concept screening and concept scoring. So, it is more fine grained. Okay. So, this is the one we choose to develop, okay, concept DF, a combination of D and F.
To summarize this lecture, although concept generation is an inherently creative process, teams can benefit from using a structured method involving steps such as clarifying the problem, searching externally and internally, and systematic exploration following that, and that followed by reflection on the process. After successful concept generation, one needs to follow a structured concept selection process to select the best of the concepts that have been generated. So, this will lead to a successful design. And this process involves evaluating concepts with respect to customer needs and other criteria, and selecting one or more concepts for further investigation or development. There are 2 types of concept selection. One is concept screening and the other is concept scoring. Concept screening typically uses a reference concept to evaluate various concept variants against selection criteria, and typically this involves creating a matrix that we saw during the lecture, which is known as a Pew matrix. Now, once you have done that, then you may use concept scoring to do more refined concept selection, and this typically uses different reference points for each criterion. Okay. So, that brings us to the end of this lecture. So, thank you all for coming, and see you all in the next class.